Good day, viewers, and good day, class. This is JAMB Physics 2022, question number 1, JAMB Physics. And we said, for which of the underlisted quantities is the drive unit? Look at the unit, the drive unit. Correct. I, moment of a force. I, work. I, acceleration. The now option A, they said I only. Option B, I only. C, I only. D, I and I. Let us know which one is the correct answer. But before then, let's go into what we call the detail of the unit. We said fundamental units. Fundamental units, which we call fundamental, is what we call fundamental units. This fundamental is also called basic units. And in my own term, I call it Adam. Fundamental units are those units that is not drive, rather they are on their own, just like Adam. Then why drive units are those units that is being derived from the fundamental units. Are you get what I'm saying? Those drive units are those units that is derived from the fundamental unit, either by multiplication of two or more fundamental units, or division of 2 or more fundamental units, or multiplication and division of 2 or more fundamental units give us drive unit. And I say drive unit is if, because they are derived from Adam, which is fundamental unit. Also, I begin to talk about, let's go into this first. I said basic units. Basic units. We have 7 basic units. We have 7 basic units. Can I give you the name of that 7? Let me rush it immediately. 7 basic units. I have this to be basic units. Basic quantity. Basic quantities. These are basic quantities. And this is basic units. Basic units. Or what we call XI units. Or what we call XI units. Then this one is a dimensional symbol. Dimensional symbol of that. Dimensional symbol. Let's look at it. This is the dimensional symbol. This dimensional symbol. I have the basic unit, which is number 1. I say length. Length. Number 1 is length. And what is the unit? His unit is meter. Meter. And abbreviation is M. Then dimension is capital L. The second one is a mass. Mass. And what's the unit? Kilogram. Kilogram. And abbreviation is kg. And the dimension is capital M. Number 3 is time, which is seconds. Time. And the unit is seconds. Time is measured in seconds, and the abbreviation is seconds, X. And the dimension is capital T. Number 4 is temperature. Temperature. We talk about temperature, and we measure in Kelvin. Kelvin, and I can use it at theta. And dimension, no. Number 5, we have current, electric currents. We have electric currents. Electric currents, which is unit is ampere. The unit is ampere, and we use A to represent the dimension. Number 6, I talk about illumination. 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 Luminous intensity. Luminous intensity. Luminous intensity. Luminous intensity, and the unit is candela, and the abbreviation CD, no dimension. Number 7 is amount of substance. Amount of substance. The unit is mole, and this is the basic unit we have. There are 7 in number, as I mentioned. But the major thing we are going to have in our mind today is this three. And that three is a what? Length, mass, and time. And remember, when we talk about length, you look at this. When we talk about length, length is the same thing as distance. When I talk about distance, I'm talking about length. When I'm talking about radius, I'm talking about length. When I'm talking about depth of a river, I'm talking about length. When I'm talking about breadth of a house, I'm talking about length. When I'm talking about displacement, I'm talking about length. When I'm talking about distance, I'm talking about length. When I'm talking about radius, I'm talking about length. When I'm talking about diameter, I'm talking about length. All these are called what? Length. But they use this different name to what? Categorize them in a different dimension. But they are length. And they are measured in meter. Get me right? All these things I mentioned now, they are what? Length. And they are measured in meter. And their dimension is L, so that you will not be confused anytime. When I talk about what? Diameter, that's the length for you. When we talk about radius, that's the length. When we talk about width, that's the length. Then we talk about breadth, that's the length. Okay? You noted it. So this is the fundamental unit which I called Adam. These are built on their own. Nobody created them. They are what? Adam. Then now, I call to what? Derived units. Let's see what we call derived what? Units. These derived units, I call them what? If, which is derived from what? Adam. We say derived units are those units that is derived from what? Fundamental units. Either by multiplication or division or combination of multiplication and division of one and two or more what? Fundamental units. So we go to that. Let me give you an instance. Look at derived quantity. I come to derived quantity. I come to what? The units, and I come to dimension. Look at it. Let me just rush it immediately. I said derived quantity, derived quantity, derived quantities. These derived quantities, and this is what? Derived units, derived units, derived units, and this is what? Dimension, dimension, dimension. Are you following now? I come to this number one. Let me look at what? Area. Area. And what's the definition of area? Definition of area is what? Length times what? Breadth. I think that we know. I get what I'm saying now. And what is breadth? Breadth is the same thing as what? Length. And I can say what? Length times length. Right? This breadth, as I mentioned, is the same thing as what? Length. That means length times length. Then, what's the unit of length? We say meter times what? Meter. And this area become what? Meter squared. So the unit of area is meter squared. We have meter what? Meter squared. Meter squared, which I write like this. Let me just know regarding the word. Write meter what? Squared. Then now, dimension is what? L squared. Because dimension of meter is what? L. Then you remember, and I come back again to what? Volume. Let's look at volume. Volume is given as length times breadth times what? Height. And this simply means length times what? Length times what? Length. I told you that breadth is something as length, height is something as length, and this gives me meter times meter, and that gives me what? Meter what? Cube. I can now say that the unit of what? Volume is what? Meter cube. So when somebody now tell me that he has 20 meter cube, automatically I have already know that that person is talking about volume. Then dimension of it become L cube. I think you know the importance of we looking for the unit. Without unit in anything in physics, that thing become what? Useless. Like as a human being, all of us have name. Our name is what we use to identify where we are coming from and who is who. So without units in physics, it's become what? Nothing. So the magnitude and the unit need to go ahead. So let's go to this. Another example, I come to what? Velocity. Let's see velocity. Velocity. And what's the velocity? Velocity is a what? Displacement. Displacement over time. Displacement over time. That's the velocity. And what's the unit of displacement? Displacement is the same thing as what? Distance. And is measured in what? Meter. Are you going to say now? And the time is what? In seconds. Therefore, I can now say that the unit of what? Velocity is what? Meter per what? Seconds. And or I can write it this way, meter per seconds, or I can write it meter per seconds. I think you know. This is meter per seconds. If I'm talking about what? Indices, I can write this way. Then the dimension can be what? Length all over what? Time. Or I can write it like this, length t minus 1. Are you there? Then now, I come over to what? Acceleration. Acceleration. I have acceleration. Acceleration. This is acceleration. And we say, what's the definition of acceleration? We say what? Velocity. Velocity over what? Time is acceleration. And I can now say that the unit of what? Velocity is what? Meter per seconds divided by what? Seconds. That's what we are saying here. Meter per seconds is the unit of velocity, and the unit of time is what? Second. And this thing is same thing as meter divided by seconds divided by what? Seconds over 1. This thing can be written this way. And the same thing as what? Meter per what? Seconds times 1 all over what? Seconds. And this will give me what? Meter per seconds what? Square. That means that unit of what? Acceleration is what? Meter per seconds what? Square. Or I can write it meter per seconds minus what? T. Then dimension can be written as what? L all over what? T raised to what? 2 or what? L T minus 2. That's the dimension of what? Velocity. Somebody will ask, how did I get this? You remember, if you come down here, if I have L over L over meter T, I can write this as what? Let me come to this. Let me use this to illustrate. If I have M over what? Second, which is what? The unit of velocity. I can write this as what? M over 1 times what? 1 over what? This. And this is something as what? You remember that indices that said that if we have 1 over A, that is something as A raised to the power minus 1. So this thing I write here can be written as what? M times what? X raised to the power minus 1. And that will give me what? M x raised to the power minus what? 1. You remember that anything divided by 1 is that gives me M. This 1 over x is 1 over A is given to what? A raised to the power minus 1 through indices. That's how we can be able to write this as what? This. The same thing applicable on this one as we did, it will be now raised to the power minus 2. Clear? Then if we know this fundamental thing, we can come back to our questions and what? Deal with the question they asked us over here. But another thing you needed to know here, another thing I want us to know here is that I can't be able to get a dimension without knowing the unit. I can't be able to get dimension without the unit. It's from the unit I be able to get what? The dimension. Therefore, I can't be able to get the unit without definition. So I will first of all define a quantity before I can be able to get its what? Unit. And from its unit, I get what? Dimension. What am I saying actually? I said from the unit, we get dimension. And from the definition, we get the unit of a quantity. So I can't get a dimension of a something or quantity without getting its what? Unit. And I can't get its unit without getting its definition. So you see how we started. Velocity, I have to define velocity. From its definition, I'll be able to get its unit. From its unit, I get its what? Dimension. Just like if I'm giving a dimension, I will go back to the unit. From unit, I get the definition. That's it. But let's go back to what they asked us here. The question says here, for which of these underlisted quantity? Another important thing I needed to do without wasting time is that when a quantity has the same unit, A quantity that has the same unit must have the same dimension. A quantity that have the same unit must have the same dimension. Just like work done is measured in joule. Then energy is measured in what? Joule. That means that work done, dimension of work done is same thing as dimension of what? Energy. You remember that energy has kinetic or potential. Whether kinetic or potential, they are all measured in joule, and all of them will have the same dimension. So any quantity that have the same unit have the same dimension. Another example, when we talk about impulse and the momentum, you know that the unit of impulse is same thing as the unit of momentum, which is what? Newton seconds. The unit of impulse is what? Newton seconds. And the unit of momentum is Newton seconds. Therefore, the dimension of impulse is the same thing as the dimension of what? Momentum. Is that clear? So, if I get the dimension, you note it now. Like, can I go to the question now? I'm going to look at this. What they give me, look at the dimension. They give us the dimension. Look at the dimension. They said, for which of the underlisted quantities is the derived unit? Look at the dimension. Are you get what I'm saying now? Then correct. I will now, from this dimension, I will get the what? The unit. From the unit, I get the what? The definition. Remember what we said. Look at the dimension they give me, and all squared and t minus what? T. And this implies that this man is kilogram, that's the mass measured in kilogram. This man is what? Meter squared, and this one is what? Seconds what? Minus 2. And this implies as well, are you following me? That this is what? Kilogram, meter, seconds, all over what? Seconds what? Squared. You remember? Are you following now? And this implies for this man to have seconds squared, that means acceleration is involved. For this man to have seconds squared, that means acceleration is involved. That means that what? K, acceleration, kg, what will happen to acceleration? I have acceleration to what? Meter per what? Seconds. What is the acceleration? Which covers this man. Times what? Meter. This times this will give me meter squared. This will now be over 1. Are you get what I'm saying? This is over 1. You remember, I have written this way. Are you following me? And this is over 1. This is over 1. If you times it, you get back. Meter times meter will give me this. And this implies that kilogram acceleration, which is mass. This kilogram become mass, is the mass, times what? Acceleration, which is g, then times what? The meter. And what's the meter? You remember that the mass times what? Acceleration due to gravity times meter simply mean the same thing as what? The mass times acceleration due to gravity times distance. What is measured in meter is what? Distance or length. Then what do we have? Mass times acceleration is what? Force. Mass times acceleration is what? Force. You remember that force is equals to mass times what? Acceleration due to gravity, or mass times what? A. Are you getting saying that? So mass times this is what? Force times what? Distance, which is measured in meter. Then from here now I see that force times distance is work done, right? That means that work done is equals to what? Force times what? You remember? Times what? Distance. Work done is force times distance. You see how we arrive on this? So this is the work done. Are you getting what I'm saying? So the unit of this dimension is what? Work done. And you remember that work done have a unit called what? Joule. The unit of work done is joule. Then you look at this. They say moment of a force. Moment of force as well is also what? Has its own unit to be what? Joule. Therefore, the dimension of work done is same thing as the dimension of what? Moment of a what? A force. And what do we call a moment of? The moment of a force is a force times what? Distance. Just like when we have a couple, look at your tap at home, which have this. If you want to open your tap at home, you will have this, which this becomes force 1, this one becomes force what? 2. This is how you open your tab, and this becomes focus. You open your tab at home like this, your tab, your pump, you open it. So what do we call this kind of force? We call it couple. And that moment of what? Moment of a force become what? Moment of Fp is equals to force times the distance between the focus and this, which is what? R. I get what I'm saying? Moment of force is what? Force times what? Distance, which is the radius from here to here become what? The radius of this fulcrum. And this is where the knot is starting. And this is the force. Then I would then say this force times what? The R give me the what? Moment of what? Force. And this moment of force is same thing as what? The work done, which is force times what? Distance, which is measured in joule. Therefore, since this man have a unit called what? Joule, and the work done has a unit called what? Joule, they have the same dimension. And this dimension give me work done. Therefore, this dimension will give me what? Moment of a what? Force. Therefore, the correct answer here is what? Work done and what? Moment of force. And when you look at it, option D, which is what? 1, which is I, moment of a force, I, the what? Work done. And our answer for this is what? D, which is option what? Moment of what? A force and work done. These two will have the same what? Dimension of this. I think we are clear from this now. You remember what I said? Always remember this, that every quantity, any quantity that have the same unit must have the same what? Dimension. And every quantity is derived from its definition. From its definition we get is what? The unit. From its unit we get its dimension. The same thing will go from what? Dimension to unit, from unit to definition. And that's what I did here. You see, from dimension I get to unit. From the unit we go to what? Definition. And we find out that is what? Work what? Done. Thank you. Let's go for the next question number 2. Yeah, question number 2. Question number 2 said, which of the following quantity has the same unit as the was? Which of the following quantity has the same unit as the was? And A, option A, force times time, option B, force times distance, option C, force times acceleration, option D, force times velocity. Let's go to solution. Okay? And what is watts? Watts is the unit of power. That's first thing. The unit of power is what? Watts. And what is power? Power is the rate of what? Dissipating what? Energy. That's what we call power. And we have different what? Power. Different power we have. We say power is the rate of dissipating what? Energy. The rate which energy is being what? Consumed. We are being what? Dispersed. Is called what? Power. And we have different types of what? Power. We have mechanical power. We have what? Mechanical power. Mechanical power. Which is equals to what? Mechanical energy over mechanical energy over what? Time taken. Time what? Taken. Reset. Mechanical energy over time taken. And what is mechanical energy? Mechanical energy is work done, which is what? Work done, which is force times what? Distance over what? Time. Are you following? And then what is this? This is something as what? Force over 1 times what? Distance over what? Time. And what is distance over time? Distance over time is a what? Velocity. Distance over time is what? Velocity. Therefore, I will have this to be what? Force times velocity, which is the same thing as what? The watts, which will have the same unit as what? Watts, which is power. Force times velocity is power, which is unit is what? Watts. And when you look at this option, we have force times velocity as option D. Then we say that our answer is option what? D, which will have the same unit with what? Watts. But also you know that we have, after mechanical power, we have what? I say mechanical power. After mechanical power, we have what we call electrical power. Electrical power Electrical power, can we learn that as well? Electrical power, let's add it over there, is equals to the rate of what, which we call what? Electrical energy over time taken is also that. And what is electrical energy? Electrical energy is current times voltage times what? Time. Current times voltage, this is voltage, this is time, over what? Time. And this man will destroy this man to give me current times voltage. That is what? Electrical power. This is the voltage. This symbol is what? Voltage. And this is what? Current in ampere. Current in what? Ampere. Current in ampere. As well, we have also what we call fluid power. Fluid power. Fluid what? Power. Fluid power is being found in a what? Hydraulic machine, just like a excavator. Excavator machine, you will see the hydraulic doing the excavation hands to tip the ground, pick it and put inside a what? A tipper. The excavator will go and dig ground and do like a human hand and carry what? A sand and put inside a what? A tipper. That operation, what is operating it is what we call fluid. And that fluid is operating on the principle called Archimedes what? Principle. Remember that. Then now, we have fluid power equals to what? Pressure times area times what? Velocity. That's what? Pressure times area times what? Velocity. This is the pressure, this is the area, that is the velocity. If you look at the air, from what we have here, we have mechanical power to the what? Mechanical power to the force times what? Velocity. Are you getting me? Force times velocity is mechanical what? Power. Then you remember that what? Pressure is equals to force over what? Area. Making the word force subject of formula, I have that force is equals to pressure area. If I take this force area to substitute the force over here, if I take it to substitute force over here, I will have that mechanical power, which is fluid power now, is equals to P area times what? Velocity. And this man is a velocity, you remember? And that's our answer, which we have already given our answer to the what's option D. But this is to give you more information about power. That's what we have mechanical power, we have electrical power, and we have fluid power. And fluid power is calculated as what? Pressure in Pascal. The unit of pressure is Pascal. Area in meter cube and velocity in meter per seconds. And the mechanical power is Dex, which is in what? In watts. Let's go to question number 3. Yeah, question number 3. The value of x, y, z respectively in the expression Dex, which is the dimension for the universal gravitational constant G, are the option is given to you. This simply means that we should what? Get the what? The dimension of gravitational constant. And where do we get gravitation of universal constant? From the Newton gravitational force. Newton gravitational force said that 8 pull on a body, that's 8 pull on a body. 8 pull on a body in the earth is directly, which is force on a body on the earth, is directly proportional towards the mass of the earth times the mass of that body in that earth over the distance of separation square. And the constant of proportionality, which is called what? Gravitational constant, is applied. And we have this to be what? Newton gravitational force is equals to what? G, which is constant of what? Proportionality, which is called gravitational force constant, and the mass of the earth and the mass of the body in the earth, all over R, distance of separation of the mass of the earth and the what? The mass of the body on earth. Then making the gravitational, universal gravitational constant subject of formula, I will have that this is over 1. You remember, anything divided by 1 is that thing, cross multiplication. I will have that G, capital M minus small mass, is equals to what? F times what? R squared. And making G subject of formula, I will have that F times what? R squared all over what? Capital M and small m. And this is the same thing. You remember that force is the same thing as mass times what? Acceleration due to gravity times what? R squared all over mass of the earth and the mass of the body. And this is the mass, this is the mass. It will cancel. G is equals to, now this have cancelled this, will have G R squared all over the mass, and this will be the same thing as G R squared divided by the mass of the body over 1. What's the unit? The G, acceleration due to gravity, is meter per what? Second squared times this man is meter squared divided by kilogram over 1. That's the unit of mass, is kilogram over 1. This meter times what? Meter squared times meter will give me what? Meter cube all over what? X squared divided by kilogram over what? 1. And this will give me meter cube all over what? Second squared times 1 all over kilogram, and this will give me meter cube all over what? Second square kilogram. And the unit dimension now will be what? From this I can now get dimension, which is what? Length cube, and the seconds is what? T squared, and the kilogram is the mass, and this will land me to what? 3, and the T 2, T minus what? 2, this become T minus 2, and M minus what? 1. And that's the what? Dimension of what? The gravitational constant. I can now say that M, which is given to me, and L, Y, and T, Z, is equals to the same man of these 3, T minus what? 2, M minus 1. Are they the same base? Yes. Look at the base. MLT is the base. LMT is the base. You look at it. This man I write here can be written this way. If you want, you can write it this way. That's the same thing for correction. I have this to be M minus 1, and this can be what? L3, and T minus what? 2. These are the same thing as this. So they have the same base. Which is their base? MLT. Base MLT, the same base. And since they have the same base, remember that what? This equation said that if we can make the two sides of the equation of the indices to have the same base, that automatically their power is equal. If we can make them to have the same base, two sides of the equation to have the same base, automatically their power is equal. Therefore, I look at them, they have the same base MLT, base MMT, so automatically their power is equal. And now I have to equate it. That means that X, that implies that X is equals to what? Minus what? 1, and the Y is equals to what? 3, and the Z is equals to what? Minus 2. Are you get what I'm saying? I'm equating them now. This is T raised to power Z. The Z is minus 2, and the Y is 3, and the X is minus 1. Therefore, what option do we have? I have that this option B, which is what? X minus 3, minus 1, and the Y is 3, and the Z is 2, which I can now write this to be minus 1, comma 3, comma minus what? 2, and that's my what? Answer. What is the answer? Our answer is what? Option what? B. Let's look for what? Question number 4.